Hello everyone. In this lecture we shall discuss the Gauss-Jordan elimination. Okay. Basically this Gauss-Jordan elimination is used to find the inverse of a matrix. And what is the idea? If you recall your previous knowledge of your higher secondary, what is A inverse? Is your adjoint A divided by your determinant of A. Okay. So this is the aspect here, but here we want to solve it by using the Gauss-Jordan elimination. Means you are given a matrix A, right? You are given a matrix A, and the same order identity matrix you write here. Okay, the same order identity matrix you write here. Now we want to find the inverse. The condition is same. First of all, a determinant of A is not equal to 0. Determinant of A not equal to 0. Then only this matrix is called non-singular. So every non-singular matrix first, okay, is row equivalent. You apply the set of row operations here. We apply the set of row operations here. Now if you apply the set of row operations and we try to bring it the identity here, right, then whatever the thing will come here, this will be the inverse of the matrix, right? So the basic idea is, as you know, every non-singular matrix is row equivalent to an identity matrix of same order, right? So on the other hand, if the same set of operation is applied to the identity matrix, so here the same set of operation to applied to the identity matrix, then it gives me the inverse of the matrix. It gives me the inverse of the matrix. Okay, so this is the basic knowledge of your Gauss-Jordan elimination. So Gauss-Jordan elimination is used to find the inverse is one aspect. The second aspect is to find the solution of a system of equations. At this juncture, you should recall the Gauss elimination method, our first lecture, the Gauss elimination technique to find a system of linear equations. Okay, so this is the better one, and this Gauss-Jordan elimination method is also used to find the inverse. Okay, but it will be lengthy. So here this we'll use this Gauss-Jordan elimination to find the inverse. Now let me to tell you the exact procedure for the same. As you know, if A is non-singular, A must be a square matrix. That is determinant of A is not equal to 0. Then here A inverse exists. Okay. So now A into A inverse is identity, and this is matrix multiplication is being commutative. It is A inverse into A, right? So this is the principle here, right? Means what is the technique of Gauss-Jordan elimination? You are given a matrix A. What is the working rule? I rather say working rule. You are given a matrix A. You gently press a line here and you write the identity matrix of same order. If this is of order n cross n, you write this is of n cross n identity matrix. Then you apply here the elementary row operation. I have repeatedly told you, you may interchange any two row. You may replace a row by a scalar multiple of that row and that row, and thirdly, you may increase or decrease a row by scalar multiple of other row. Okay, this you may decrease also, and in view of this property 2, you may also multiply a constant here. So this k1 and k2 is not equal to 0. So you should see this thing in my earlier lectures. Okay, to make it self-sufficient, I remind you this technique here. So now by the set of elementary row operations, okay, what you will get? You try to bring the left hand side as the identity matrix like this. Okay, then what will happen? Whatever thing will come here in the right hand side here, this will be my A inverse. So this is the working rule to find the inverse of the matrix by using the Gauss-Jordan elimination. This is my Gauss-Jordan elimination, right? So let me to solve one example, then your idea will clear. You are asked to find the inverse of this matrix. Okay, so come to the solution. We have to first see what happens to the determinant. Let this is my A. So what happens to my determinant of A? Determinant of A is my, as usual, 1 into 2 minus 3 minus 2 4 then here minus of minus 1, this is minus minus plus 1 of this and this removed, it is 2 minus 3 minus 2 4 plus plus twice, it is 0 2 3 minus 2, and you simplify it, you simplify it, and this determinant will give you your 1. I am telling you an trick to find the determinant to avoid here, to save your time. Means you are given 1 minus 1 2, 0 2 minus 3, 3 minus 2 4, 3 minus 2 4, and how to find the inverse of the determinant of the matrix? You just write this 1 and 3 here simply, okay, and you write this 2 and 4 here, 2 and 4 here, and you just multiply it in this way. This is here 0. What is the determinant now? This is here 0. If you multiply this 0, then you multiply this will be your plus 8, then you multiply this will be your plus 9, then come to this side, then put a negative sign here, you come to this side, you multiply this, it is here 0, you multiply this, 2 2 ja 4 into 3 12, then you multiply this 6, it is 17 minus 18 is minus 1 is not equal to 0. This is actually just a confirmation test. So this implies A inverse exists. Okay. Now we are ready to find the inverse. Now consider the matrix A together with the identity matrix of same order. It is 0 1 minus 2, it is 0 2 minus 3, 0 2 minus 3, it is 3 minus 2 and 4. Actually this is here 1, this is here 1, so this is 1 minus 1 2, 0 2 minus 3, 3 minus 2 and 4. Okay, so with this same I want to write the same order. Gently press a dotted line, I write a same order identity matrix, and I want to bring the left hand side an identity matrix, right? So use this to bring this position, already it is 0, bring this position 0. So what we have to perform here? Here R3 is replaced by, if I multiply 3 with R1, R3 minus 3 times my R1. So after simplification, row 1 remains silent, 1 1 minus 2, the same operation will be performed here, it is 1 0 0, and row 2 remains silent, 0 2 minus 3, it is my 0 1 0, and row 3, this 3 minus 3, it is my 0, it is 1, it is minus 2, it is minus 3, it is here 0, and it is here 1. In the next step, what we have to perform? Use this position to bring this 0 and bring this 0. Okay, use this position. So what will be the operation? Here R1 will be replaced by, if I multiply 2 over here, okay, if I multiply 2 over here, it is 2R1, and 2R1 actually this is here minus 1, so this is here minus 1 here. Okay, so now this is 2R1 plus R2, I multiply 2 here and add it, then my R3 is replaced by 2R3 minus R2. So your middle row remains silent, 0 2 minus 3, 0 1 0, and here you applying this my 2R1, I multiply 2 here, 2R1 plus R2, now it is my 0, and it is my 1, and it will be 2 1 0, and here likewise 2R3 is 0, 2R3 minus R2, it is here 0, it is here 0, it is minus 1, it is minus 6, minus 1 and 2. Then the next step will be use this to bring this item 0 and this item 0. Okay, so now my R1 is replaced by simply R1 plus R3, it is 1 here, it is minus 1 here, and here R2 is replaced by, I multiply 3 here, simply it is R2, and I multiply 3 and subtract it, minus 3 R3. Then my row 3 my remain silent, 0 0 minus 1, it is minus 6 minus 1 2, this is my remain silent. Now R1 plus R3 I simply add it, it is 2, it is 0, it is 0, it is simply my minus 4, it is my 0, and it is my 2, and the middle row will be R2 minus 3 R3, it will be my 0, it will be 2, it will be 0, it will be 18, it will be 4, it will be minus 6. Then the final step is my, I need to make this position 1, make this position 1, and make this position 1. So now what I have to do, R1 is replaced by half R1, and R2 is replaced by half R2, and R3 is replaced by minus R3. Then it is here 1 0 0, and here it will be minus 2 0 1, and it will be 0 1 0, just 2 is divided, it is here 9, it is here 2, it is here minus 3, here just minus is multiplied, and it is here 6 1 and 2. Now this must be the inverse. Okay, so therefore my A inverse will be equal to minus 2 0 1 9 2 minus 3 6 1 and 2. Okay, so if at all any doubt occurs, if you want to just check it for any doubt, then what you have to do, you just multiply A with A inverse. Okay, and you see it must be your identity, here, since it is a third order, so it must be your 0 0 1. If you like you can just have a check if at all you have a doubt whether you have done it correctly or not. Okay, so this is what the Gauss elimination method, Gauss-Jordan elimination method to find the inverse of the matrix. At this moment, if I recall alternatively, if I recall your higher secondary things, then you find determinant of A is not equal to 0, means A inverse exists, then you have to find the adjoint of A, you have to find transpose of cofactor, it is here transpose of cofactor transpose. Okay, then what is your A inverse, it is your adjoint A by determinant of A, but it will be a lengthy approach. Okay, but in small cases, suppose it is a 2 cross 2 matrix, some special case, if you are given a 2 cross 2 matrix, suppose you are given A is 2 3 5 4, and you are asked to find the inverse of the matrix. What is A inverse? What is a determinant of A? It is adjoint of A by determinant of A. So what is your determinant of A here? Determinant of A will be 4 2 8, so 1 by 8 minus 15, so this is my determinant of A. Then what will happen? The leading diagonal just reverse, this will come to this position and this will come to this position, and the other diagonal becomes negative, it will 4, and this other diagonal becomes negative, it is minus 3, it is minus 5, and it is 2 here. So this will be my 1 by minus 7, 4 minus 3 minus 5, 2, this will be your inverse. So this is minus 4 by 7, 3 by 7, 5 by 7, and minus 2 by 7. So this will be your inverse of A, right? And likewise, if you are given a matrix, suppose K1 0 0, 0 K2 0, 0 0 K3 you are asked. Okay, so what will be the inverse? The inverse will be simply, it is your 1 by K1 0 0, 0 1 by K2 0, and 0 0 1 by K3. Okay, this is your inverse of this will be this only. Okay, so these are the simple cases to find the inverse. Now let me to recall you some basic properties. Property number 1, AB whole inverse is B inverse A inverse. The condition is that A and B are conformable for multiplication and individually they are non-singular. And secondly, A square inverse is A inverse square. And thirdly, A inverse transpose is A transpose inverse. If I want to prove it, sometimes these proofs are important also. Suppose coming to proof 1. So here the basic thing is that A and B are such, the product is conformable, and these are inverse is also conformable. I am just writing the inverse part. We have AB into B inverse A inverse. I just multiplied. Now you know matrix multiplication is associative. So this is you can make it A B inverse into A inverse because of the associative property. Now this B inverse is I, so A inverse. Now this is A inverse, so this is your identity. It is proved now. Then coming to the proof of, so what does it mean? Means we are getting AB into B inverse A inverse is my identity. So this has to be, this implies this B inverse A inverse is the inverse of AB. But inverse of AB is really what? AB inverse. So this B inverse A inverse is my AB inverse is proved now. Now coming to your proof 2, you have AB inverse is B inverse A inverse. If I put A is equal to B, then what will happen here? It is my A square inverse is A inverse into A inverse is A inverse all square. So proof 2. So it is now proved. Now coming to proof 3. You know we have A inverse is your identity. So now if I multiply, if I take the transpose to both sides, so you know AB whole transpose is B transpose A transpose. It is A inverse transpose into A transpose is your I. Okay. Now if I bring this to this side, so my A inverse transpose is A transpose inverse. So this is my proof now. Okay. So let me tell you how this Gauss-Jordan elimination is used to solve a system of equations. Suppose you are given a system of equation A11x1 plus A12x2 plus A13x3 is equal to B1, A21x1 plus A22x2 plus A23x3 is equal to B2, A31x1 plus A32x2 plus A33x3 is equal to B3. So now what we have to do, we consider the augmented matrix. Consider AB. For simplicity I choose a 3x3 matrix here. So it is my A11, A12, A13, A21, A22, A23, A31, A32, A33, and I gently write my B1, B2, B3. I gently write my B1, B2, B3. So what we have to do is, we just adopt the elementary row operation, and proceeding in the same way. Can we not make it my 1 here? Can I not make it my 1 here and my 0 and 0? And suppose I get my B1 dash here, the changes. Then similarly I bring it 0 1 0 and this changes will be suppose this, and I bring it 0 0 1 and the changes will be my this. Okay, then what will happen? So as per the working rule of Gauss elimination method, can we not bring it? So now bring this as an identity matrix. Then what will happen here? Now so this implies my x is equal to my B1 dash, and second row will give me y is equal to my B2 dash, and third row will give me z is equal to my B3 dash. Okay, I am not discussing this Gauss elimination method to find the solution of a system of equation. As solving a system, coming to my, you recall my lecture 1 where I have discussed the Gauss elimination method. Gauss elimination method, right? Gauss elimination method. So this solution of the system of linear equations, you should refer to my lecture 1 where I discussed the Gauss elimination method and varieties of problem of Gauss elimination method to solve a system of equations. But this Gauss-Jordan elimination we basically use to find the inverse. If at all it is asked to find the solution, then we should move like this. We write the augmented matrix and we bring the coefficient matrix to simply an identity matrix, then the changes will be occurred. Suppose b1 dash, b2 dash and b3 dash. Now just then simplifying, my x is my b1 dash, y is my b2 dash and z is my b3 dash. Okay, so we should close here. In our forthcoming lecture we will discuss the most important aspect is my eigenvalue. My next lecture will be eigenvalue and eigenvectors. So this eigenvalue and eigenvectors are most important in linear algebra. It has wide applications. So you should watch my next subsequent video on eigenvalue and eigenvectors. So I should close this lecture here. Before closing, I request all of you, if you find this lecture is interesting and it is useful to you, you just subscribe this channel so that it will give me a motivation to prepare further lectures and upload the same in YouTube for your benefits. And this motivation will help me for further lectures to prepare, and at the same time you will get the notification on your screen. Then whatever the lectures will be uploaded, you will just get a notification and you can watch it, right? So thank you all. Have a nice day.